All right, let's talk about running your applications in the cloud. We're going to climb what I like to call the cloud computing ladder, starting from the ground floor and going all the way to the top. This is going to clear up one of the biggest questions out there. How does this stuff actually work? Okay, let's get into it. So, you've got this great idea. Maybe you've even written the code, and now you want to get it out to the world. But you log into a cloud provider and you're just hit with this giant menu of options. It's a lot, right? Do you need a whole server or maybe something smaller? Or what about something you don't even have to think about managing? That's exactly what we're going to demystify today. And here's how we're going to break it down. We'll start with the foundation, the bedrock, virtual machines. Then we'll climb up a level to the super efficient world of containers. From there, we'll hit the top floor with serverless. And then at the end, we'll tie it all together so you know exactly how to choose the right path for your own project. Okay, first up, the foundation. Virtual machines, or VMs for short. The easiest way to think about a VM is that you're basically renting a computer in the cloud. It's the digital version of that physical server that used to sit in a closet somewhere. But hang on, before you can build your house, you need to own a piece of land, right? Well, in the cloud, that's your virtual private cloud, your VPC. It's your own little private, isolated corner of the public cloud. It's where you set up your own network, your own security rules. It's your digital property line. And the house you build on that land, that's a Google Compute Engine instance. This is your VM. And this is where you see just how much control you really get. I mean, look at this. You get to choose your operating system, Linux, Windows, you name it. You decide exactly how much CPU power and memory it has. You attach the storage you need. It is total, granular control, and you only pay for it by the second. And that control even extends to how you pay for it. You're not just stuck with one price. If you have an app that's just going to run 24/7, you automatically get sustained use discounts. If you know for a fact you'll need that server for the next 3 years, you can commit to that and get a massive discount. And my personal favorite, for jobs that can be interrupted, like some big data crunching, you can use spot VMs and save up to 90%. The bottom line is, you can match your cost to exactly what you're doing. Okay, but managing an entire operating system for every little piece of your application, that can be a bit much. It's kind of heavy. What if there was a more efficient way? Well, there is. Let's climb up to the next rung on our ladder, containers. This is, hands down, the best way to think about a container. It's just a box. You put your application code in it, and you also pack in every single library, every file, everything it needs to run. And the magic of this is, that box will run the exact same way on your laptop, on your coworker's laptop, on a test server, or in production in the cloud. No more, well, it worked on my machine problems. Now, this whole box idea completely changes how we think about handling more traffic. With a VM, the old way was to scale up. If you needed more power, you just made your one server bigger and beefier. But with containers, we scale out. We just add more boxes. So if your app suddenly goes viral, you don't try to build one giant mega server. You just instantly stamp out 1,000 copies of your little container. It's way more flexible and resilient. Okay, so this sounds great, but now you've got thousands, maybe tens of thousands of these little boxes running around. How on earth do you keep track of all of them? How do you update them or connect them to each other? Well, that's where an orchestrator comes in. And the king of orchestrators is Kubernetes. I know, Kubernetes can sound really complex, but honestly, it comes down to these 3 basic ideas. First, your container gets wrapped in something called a pod. That's the smallest thing you can work with. Second, you use a deployment as a blueprint. You just tell it, hey, I always want 5 copies of this pod running, and Kubernetes makes it so. And finally, a service puts a single, stable address in front of your group of pods so traffic can actually find them. That's it. That's the engine that makes all that scaling out stuff really work. Now, actually setting up and running Kubernetes itself, that can be a whole job. I mean, a serious, full-time job. And that's exactly why services like Google Kubernetes Engine, or GKE, exist. GKE is a managed environment. Google takes care of all the messy, complicated stuff underneath, so you can just focus on your pods, your deployments, and your services, not on patching the orchestrator itself. So we went from managing a whole virtual server down to managing these little container boxes. But what if we could climb one more rung up the ladder? What if we could just forget about all of it? No servers, no containers to manage. Welcome to serverless. This right here is the whole promise of serverless. You just focus on your code, the good stuff. The cloud provider takes care of absolutely everything else. Provisioning servers, scaling them up, scaling them down. It's all completely abstracted away. You just get to be a developer. And a service like Cloud Run makes this ridiculously simple. I mean, look at this workflow. Step 1, you write your code. Step 2, you package it into a container. Yeah, it still uses containers, but you never have to manage them. And step 3, you deploy it. That's it. Google gives you a secure web address, and it handles everything. It scales up to handle 1 million requests, and this is the cool part. It scales all the way down to 0 when nobody's using it. And this is where the billing model will just blow your mind. You pay only for the exact time your code is actually running, and it's measured down to the nearest 100 milliseconds. Think about that. If nobody hits your website for an hour, you pay exactly 0 for that hour. It is the definition of pay for what you use. Now, in the serverless world, you'll mainly see 2 flavors. You've got Cloud Run for your whole web applications, your website, your API backend, and then you have Cloud Functions. These are for tiny, single-purpose bits of code that just react to events. A perfect example is a function that automatically creates a thumbnail every single time a new image gets uploaded. It just wakes up, does its one job, and goes back to sleep. Phew. Okay. We have climbed the entire ladder. We went from the raw control of a VM, through the efficiency of containers, all the way to the pure abstraction of serverless. So the big question is, how do you choose? Let's put it all together and figure out which rung is right for you. And really, it all boils down to this one fundamental trade-off. It's a constant balance between control and convenience. Over on the left, with virtual machines, you have maximum control. Every setting, every package, it's all up to you. That's great for old legacy apps, but it's a ton of management overhead. As you move to the right towards serverless, you give up that fine-grained control, but in return, you get incredible ease of use and that amazing pay-per-use cost model. And containers, they're that sweet spot right in the middle. You get the portability for modern microservices without having to manage the entire OS yourself. And so there you have it. That's the map, from the foundation all the way to the top. So the only question left for you is this. That next great idea you've got rattling around in your head, which rung of the ladder are you going to start on?